Okay, so I already recorded this video once and it messed up. So I apologize. I'm going to have to go through this kind of fast because I don't know what happened. So for number one, we have Josh is a cartoon artist and he's completing his, he's drawing cartoons. And so he's recording how many cartoons he draws. So every 20 minutes, he's recording the number of cartoons that he draws. And you had to kind of change this because I had balloons over here on the side. So you can see where my points are graphed. And then for number two, it has us draw a line of best fit. So you can see in green where I drew my line of best fit. So then it says for number two, how many can you draw in 2 hours? Remember, 2 hours is 120 minutes. So here's 120 minutes, which hits this point right here, which is about 24, 26. If you got somewhere in this range right here, it kind of depends on where your line of best fit is. But as long as you got in that range right here, you're okay. So I got 26, but I would say if you got somewhere between 22 and 26, you're okay. Number three, Sage belongs to a bird watching club. Every 2 days, she goes out and counts the number of black hooded parakeets she sees. The scatterplot shows the number of parakeets she saw in the past 12. It should say days. Use the graph to estimate the number of days it will take for her to observe 14 parakeets. Well, here is 14 parakeets. And if you look at the graph, here's where it hits the line, which is at about day 22, because this is day 20. So this is day 22. So you would get somewhere around 22 days. If you got 20 or 24, that would be okay as well. Number four, use the graph to the right. Describe the relationship between the number of birds observed and the days. It's the help to find the slope, but really all I wanted you to see is I want you to see that as the number of days increases, the number of birds she sees also increases. Number five, use the graph to the right. Is there an outlier in the scatter plot? And if so, what is it? This is an outlier right here, and this point is at 120, comma, roughly 65. And so there's that. And then it says what type of association is shown. There's a positive linear association. As time increases, the percentage also increases. Number seven, Cory is selling his book collection. The scatter plot shows how many comic books he has left at the end of the day. So it says write an equation in slope-intercept form for the line that is drawn. So what I did is I picked 2 points, and I picked the point 3, 6, and then I picked 2, 7 because I felt like they were the closest to the line. So you find the difference of your y's over difference of your x's, which I get a slope of -1. Well, then I'm going to take that -1 and I'm going to plug it in here for my slope. And then I'm going to pick one of the points. And I picked the first point, 2, 7. So 2 is my x and 7 is my y, along with that -1 slope. So -1 times 2 is -2. Add 2 to both sides. So you get that your y-intercept is 9, which that's what it should be because 9, the y-intercept, is where it starts on the y-axis. So this is starting at 9. When you rewrite it all out, you get y equals -1x, because my slope is -1, plus 9. The more correct way, I know it's kind of hard to see, but it should be y equals -x plus 9. I understand why you would put -1x, but remember, -1 times x is -x. So it would be y equals -x plus 9, or -1x plus 9. How many comic books will he have at the end of the 6th day? Here's the 6th day. And that is 3 comic books. So he will have 3 books left at the end of the day. Now remember, if I'm going too fast at all with this, you can pause it, kind of catch up. You can rewind. So don't feel like you have to keep this going the entire time, this video. You can pause it anytime you need to. Also, while you're watching this or if at the end of it you have any questions, please email me, mathteachercoffee@gmail.com. Remember, my name is spelled Coffey, so mathteachercoffee@gmail.com. Number 9, what do the slope and y-intercepts mean, or for the line drawn mean? Okay, I'm going to start with the y-intercept first, and the y-intercept is positive 9. That's what you start off with. Well, if this graph shows how many books he has after every given day, the 9 is how many books he started off with. So he starts off with 9 books, and then this -1 is how many books he's losing each day. So every day he loses a book. Every day he loses a book. Every day he loses a book. That's what the slope means. The number of books he has is going down by 1 per day. I'm actually going to erase this part right here. Okay. Okay. So here we have a Venn diagram that compares the roller coasters at an amusement park as to whether or not they are made of steel and whether or not they have loops. So this number right here means there are 2 roller coasters that are made of steel but that do not have any loops. There are 6 roller coasters that are made of steel and have loops. There are 4 roller coasters that have loops but are not made of steel, and then there are 4 roller coasters that are not made of steel and that do not have any loops. So I'm going to look at this table, and I'm going to take the information and pull it out. So remember, this 2 is the number of roller coasters that are made of steel but that do not have any loops. Steel, no loops, is 2. There are 6 roller coasters that are made of steel and have loops. There are 4 roller coasters that have loops but not made of steel. And then there are 4 roller coasters that are not made of loops, or that do not have any loops and are not made of steel. This has a total of 8. This is a total of 8. So there are 8 roller coasters that are made of steel, and there are 8 roller coasters that are not made of steel. There are 10 roller coasters that have loops, and then there are 6 roller coasters that do not have loops. And so this is a total of 16 roller coasters. Your relative frequency is based on a grand total of whatever. So, in this problem, I told you to find the relative frequency by row. Row is what goes left to right. This would be column going up and down. Rows go left to right. So, my totals here are 10, 6, and 16. So, this number right here, steel and loops was 6 out of 10. So, when I divide 6 by 10, I get 0.6. Not steel is 4 out of 10, which is 0.4. And then, of course, 10 out of 10 is 1 whole. 2 out of 6, because again, we're using this total right here. 2 of 6 is 1/3, which is 0.33. 4 out of 6 is 2/3, which is 0.67. And then again, that total would be 1 whole. When it says to interpret the relative frequencies you found, there's so many different interpretations you could make here. Something to the effect of there are more roller coasters that do not have loops and are not made of steel than there are that are made of steel and have loops, just because the 0.67 is higher than the 0.33. So as long as you're making some interpretation that way, you could say it the backwards way. There are fewer roller coasters made of steel that do not have loops than there are of roller coasters that are not made of steel and do not have loops. So there's all sorts of ways you can go about with that. For this next one, again, I'm sorry I recorded this already, so this is why this is all written all over. And y'all are about to come back from connection, so I don't have time to sit and I'm sorry. Number 13 says, use the scatter plot at the right. What type of association is shown? And it is a negative linear association because the dots are kind of in a line and they're going down. Use the scatter plot at the right. Describe how the variables are related. If you notice, as the hours spent driving increases, the amount of gas left in the car decreases. So that would be how they related. How many gallons of gas would you expect to have left after 6 hours of driving? Here is 6 hours of driving. And so because that kind of comes over here, and actually you could use either one of these. I guess it kind of depends on how you do your line of best fit, but anywhere between 10 and 15, if you had anything between 10 and 15 gallons. The next one says to draw a line of best fit and find the slope. So I drew my line of best fit and I picked the points 4,20 and 6,15, which is right here. And I found the difference of my y's and that over the difference of my x's, which is -5/2. Remember, it doesn't matter if the negative is on the top or bottom. I plugged in my slope along with the point, and I picked the point 4,20. So I plugged in 4 for x and 20 for y, and I worked it all out and figured out that my y-intercept was 30. And so remember, this is your b, and this is your m, so I just rewrote it. So I got y equals negative 5 over 2x plus 30. All right, for 17, it's using that two-way frequency table of whether or not somebody plays an instrument and whether or not they like classical music. What is the relative frequency? Remember, relative frequencies are based on a total of a student that does not play an instrument and does not like classical music. So does not play an instrument and does not like classical music. That's 25 to the total number of students who do not play an instrument. Well, there are 31 people, because 6 that like classical and 25 that do not. That's a total of 31 people. So 25 out of 31 is 0.81. Then for 18, you're using this same two-way frequency table to answer true or false for each of these things. So for 18A, it says most of the students surveyed like classical music. That's false because there's only 16 that like classical music, where there's 29 that dislike classical music. So you would say that most dislike classical music. So that's false. Of the students that like classical music, most do not play an instrument. That is false because 6 do not play an instrument. Of the students that like classical music, most play an instrument. That is true. 10 out of 16. So most play an instrument. There were a total of 29 students surveyed. That's false because if there's 16 students that dislike music, classical music, and 29, I'm sorry, if there's 16 that like classical music and 29 that dislike, that's a total of 45 people. So there were 45 people surveyed, not 29. Number 19. Shane believes that the data collected from outside temperature and the number of people wearing coats would be a negative association. Do you agree or disagree? So what it says here is if you have temperature, so imagine this number right here is like 10 degrees and this number is 80 degrees, and here's coats. So this is like 100 people wearing a jacket. Well, if it's 10 degrees outside, you're probably going to have 100 people wearing a jacket. But if it's 80 degrees outside, you may have 1 or 2 people wearing a jacket. So as temperature increases, the number of people wearing a coat decreases. So that's a negative association. It's kind of going down. Number 20 at the bottom, you had to draw the scatter plot. So we did number of hours studying here on the x-axis, and the grade is on the y-axis. And I just had to make sure everything was evenly spaced. Notice there's a break in the graph. So I started at 60 and I went by 5s. I only labeled every other 5, but I went by 5s. So I drew my scatter plot. I drew my line of best fit here in yellow. And then it says, does the scatter plot show a positive, negative, or no relationship? And I did a positive relationship because my dots are going up. All right, on the back page, in the equation y equals 3x plus 15 could be used to describe the line of best fit for this scatter plot. So the slope is 3, and I'm going to kind of skip, and the y-intercept is 15. Now, just looking over here at this graph, if this shows number of hours and the cost of renting a jet ski, this 15, which is your y-intercept, that's your starting fee for renting a jet ski. So if you just go in, say you want to rent a jet ski, you have to pay them $15. Then you have to pay $3 for every hour that you rent the jet ski. That's what the slope of 3 means. You're going up, it's going up $3 every hour, $3 every hour, $3 every hour, $3 every hour. That's a cheap jet ski to rent. And then the last one, 22, talked about males and females and whether or not they like pizza. So we have that 25 males like pizza, while 10 do not. That's a total of 35 males. And then 40 females were surveyed. 25 of them dislike pizza, which means that 15 of them like pizza. So then you can see I just totaled up the columns. It says to find the relative frequency by columns. Remember, again, columns is up and down, round to the nearest whole number. This is actually talking about percent when it's talking about this, because if you do 25 out of 40, you get 0.63, which is 63%. So that means that 63% of the people that like pizza, they are male. 15 out of 40 is 38%. So 38% of the people that like pizza are male. And then, of course, this is 100% because that's all the males and females together. And it doesn't add up to exactly 100 because we did some rounding, but it's 100%. Does not like pizza, 29% of the males do not like pizza, and 71% of the males, of the people that do not like pizza, 70 or 29% of them are male and 71% of them are female. And then of the entire survey, 47% were males and 53% were females of the 75. So then it says, does the data support the following statement that boys like pizza more than girls? And that is true because 63% of the boys like pizza, whereas only 38% of the girls like pizza. And since 63 is higher than 38, more boys than girls like pizza.